All right, so part 2, quadrilaterals. Now we're going to really jump into quadrilaterals. We talked about quad meaning four, lateral meaning side. So a quadrilateral is a four-sided polygon. And so because it's a polygon, all four sides are straight lines, and it is a closed figure. And so lines are line segments. We know that those have to be straight. So I cannot have a curved line, right? That does not work. It has to be a straight line to be a line segment. And so my polygons are made up of straight sides. We also need to know, before we can get too far into quadrilaterals, we need to talk about angles. And so this, again, is not new like the other stuff. This is kind of review. But I have three types of angles. I have an acute angle, which is less than 90 degrees. Or smaller than 90 degrees. I have a right angle, and a right angle is exactly 90 degrees. And then I have an obtuse angle. And obtuse angles are greater than 90 degrees. So those are my three types of angles that I need to know. All right, congruent. Now later on when you talk about congruent in math, especially in 8th grade, we start doing transformations and dilations. Congruent means same size, same shape. But really congruent just means same. So if I talk about angles being congruent, they just have the same angle measure. Or if I talk about sides being congruent, then that means they have the same length. And so congruent means same. And so you'll hear that word a lot in math going forward for the rest of forever. Congruent means same. And a lot of times you'll see congruent abbreviated, or the symbol for congruent is an equal sign with this little toothpastey thing up here. So you always see in the toothpaste commercials how they always do it like that. And of course, when I try to put toothpaste, it just gets all over the place and all over the sink, and my wife gets mad at me. But the equal sign with the little toothpastey thing, that means congruent. All right, moving along, parallelograms. So we're going to talk about some specific types of quadrilaterals, the first of which is a parallelogram. Some things that we know about parallelograms. I know that my opposite sides are parallel, and so we can draw these little arrows that indicate direction, so we know that they are parallel. So opposite sides of a parallelogram, they are parallel. And then also opposite sides are congruent. So of every parallelogram, my opposite sides are parallel and they're congruent. So if this was 3 centimeters, this side has to be 3 centimeters. If this is 5 centimeters, this side has to be 5 centimeters. So opposite sides are parallel and congruent. Very important. All right, so a rhombus. Here's the first type that we're going to talk about, a specific type. A rhombus is a quadrilateral, meaning that it has 4 sides, and a rhombus is a parallelogram. So if a rhombus is a parallelogram, I know my opposite sides are parallel, and I know my opposite sides are congruent. So if that's 2 centimeters, that has to be 2 centimeters. If this is 2 centimeters, then this is 2 centimeters. But a rhombus is a special type of parallelogram because it's a parallelogram where all sides are congruent. So if I were to only give you one side of a rhombus, you would automatically know that all 4 sides are the same. So that helps out quite a bit. All right, next type is a rectangle. Now a rectangle is also a parallelogram. So my rectangle is a quadrilateral, has 4 sides. It's a parallelogram, so because it's a parallelogram, I know that my opposite sides are parallel. I know that my opposite sides are congruent. So if this was 2 centimeters, this side is 2 centimeters. If that was 8 centimeters, then the opposite side has to be 8 centimeters. So I know some really good things here. Another thing that I know about a rectangle is that it has 4 right angles. So I have 4 right angles. All right, so some very important properties of a rectangle. Now, we're going to look at a third type, which is the square. The square is a quadrilateral, has 4 sides. The square is a parallelogram. And so, because it's a parallelogram, I know that my opposite sides are parallel. And it also has 4 right angles, just like the rectangle. And another thing that I know about a square is that all sides are congruent. So if this was 3 centimeters, this would be 3 centimeters, this would be 3 centimeters. So opposite sides are congruent, but all sides are congruent in a square. Well, that sounds an awful lot like my rectangle, because if I look at both of them, 4 right angles, yep. Parallelogram, yep. So, and then opposite sides are congruent, yep. Opposite sides are parallel, yep. So a square, as we see here, is a rectangle. Now be careful, not all rectangles are squares. All squares are rectangles, but not all rectangles are squares. And we talked about that before, sets and subsets, in class, when we talked about things like all of the girls in our class are students, but not all of the students are girls. So girls is a subset of students. So again, all of the girls in our class are students, but not all of the students are girls. So all of my squares are rectangles, but not all rectangles are necessarily squares, right? But what about this here? All sides are congruent. Oh, that sounded just like, lost my little toothpastey thing. But all sides are congruent, and that sounds an awful lot like my rhombus. So my rhombus is a parallelogram, and all sides are congruent. So what that means is that not only is my square a special type of rectangle, but my square is a special type of rhombus. So that's important. A square is a rectangle, and a square is a rhombus. So very, very important. You have to know this. All right, so all of my properties of a rectangle apply to my square. All of my properties of a rhombus applies to my square. So very, very important. All right, this last one that we're going to talk about today is a little bit controversial because Texas tends to disagree with the rest of the United States, or most of the rest of the United States. So most of the United States has a very different definition of a trapezoid. And if you want to know about that, you can look it up, or you can ask me and I'll be happy to talk about it. But in Texas, a trapezoid is defined as having only one pair of parallel sides. So only one pair of parallel sides for a trapezoid. So if I have 2 pairs of parallel sides, it's a parallelogram. It is not a trapezoid. That is the definition in Texas. So if you came from a different state, learned something different, parents tell you something different, that could be why, or other countries. Other countries have different things. A trapezoid is something completely different in some other countries as well. But in the United States, and specifically in Texas, the definition of a trapezoid is one and only one pair of parallel sides. And so this side is parallel to that side. Now it's important to notice that this side and this side are not parallel. So I only have one set of parallel sides. On this other trapezoid, let's look. Is that side parallel to that side? Nope. Is this one parallel to this? Oh, sure enough it is. So it's important to notice that I have one and only one pair of parallel sides. Now that's enough for 5th grade. 6th grade, you need to know one more thing. Something else that's very, very important. It's my parallel sides of my trapezoid, very, very important, are called the bases. So the bases of my trapezoid are the parallel sides. Now don't get confused and think, oh, well, it's sitting on this right here, so this must be the base. The base must be this bottom part here. Nope, that's not true because that's not my parallel side. So the base of this second trapezoid, these are my bases, right? So my bases are going to be the parallel sides. That's extremely important. Next week, as we move even further, when we talk about trapezoids, this becomes even more important. My bases are the parallel sides of my trapezoid. And that's all we need to talk about today in this particular video. If you have any questions, please see me in the Google Meet.